pick up with part E. And if you notice, I just caught a misspelling. Did y'all see that during the minty ride? Minty ride. I guess he's chewing gum or something. During the 3-minute ride, for how many seconds was the rider above 100 feet? What was our attack there? Plan of attack. How did we accomplish that? Yeah. Every time you speak, it's with the yawn, which is good, because I speak yawnese. What we did is we graphed y equals 100 on our y sub 2, and we looked to see where it intersected our graph. I think we found these yesterday. I'm going to call it x sub 1 and x sub 2, which once we found them on the calculator, we stored them as a and b, because they're going to be ugly decimals, right? So once we store them as a and b, if I want to know for once around on the Ferris wheel how many seconds he was above 100, what would I do with my two values of a and b? Subtract them, yeah, because that would be the distance basically from a to b. So for one cycle, the time he spent above 100 would be b minus a. And then what we did is we graphed it for a full 180 seconds, and we actually counted on the calculator how many times he went around. You could compute that another way as well, just by knowing the angular velocity. And then we multiplied it by how many times he went around. Do y'all remember what that was from yesterday? 18? Yeah, he went around 18 full times. So there's our kind of strategy, mapping it out. Figure out where it intersects, subtract the two values, and then multiply by 18. Doesn't matter which x values we find in terms of which cycle. Could it be these two, or does it have to be the first two? It could be any two, right. So let's kind of go back and do that again, and I'll kind of talk you through it. I'm gonna adjust my scale, because right here the scale is pretty compressed. Let's just go ahead and look at it instead of from 0 to 180, since we know there's 18 cycles. Let's just go ahead and graph it from 1 to, what was the period? You all remember? It was 10, right? So 180 divided by 10 would be 18. That's another way you can figure out the number of cycles. Let's just graph one cycle here. So from 0 to 10, then we went from -5 to a 20. And then in Y2, I'm going to graph 100. This will make the graph less congested. Able to see things a little bit better. All right, so there's once around in 10 seconds, and then here comes 100, and now we can kind of see it a little bit better. So to find the points of intersection, by the way, you should get in this habit as well. Before you go to the calculator, you kind of need to write down what it is you're actually solving. So we wrote that down yesterday. We want to know when h of t is greater than 100. And now we can go second trace number 5. And first curve. Oops, did I do that? Second trace number 5. Okay, there it is. The first curve, it should put you on the parabola. Hit enter. It'll throw you on the second one. Hit enter. I'm going to go ahead and find the left one first. So you just kind of scroll closer to it. Hit enter. And there it is. That might be a different one than we found yesterday. I think yesterday we found it further along. So I'll just write this down right now. I'm going to call this t sub 1 equals 4.282 seconds. And then I'm going to set it equal to a. So on my paper, here's what I would expect you to do. Whichever ones you find, you don't have to call it sub 1. The sub 1 just kind of helps you keep track. T equals 4.282. So I'll be looking for that number to 3 decimal places, rounded or truncated with units. Now, if you're going to store it as a, go ahead and call it a on your paper, okay? And then make sure that you actually do store it as a. So how do we do that? If you hit second mode, you get to your home screen. And if you hit the X button, your calculator always default stores the X value in X. But if you go and find the other one, it's going to override that, which is why we store it right above the on button as alpha A. And there it is. Now if we need it, it's there with all the decimals stored. And we wrote it on our paper. Now we'll do the same thing. We'll go second trace number 5. and we'll find the second one. Enter, enter, and then scroll over closer to the second one. That looks close enough. Hit enter, and you get 5.717. So you will have to write that down. I do want to see the values you're using. I'm going to call it T sub 2 equals 5.717 if you truncate seconds. And I'm going to go ahead and call it B on my paper. So that's what I would be looking for on the free response, should you have one like this on Wednesday, and more than likely you will. Now, of course, if you're calling it B on your paper, that's because you're going to store it as B. So notice if you hit the X button again, it's a different value. Thank goodness we stored the other one as A. Store that as alpha B. Okay, so then once you have those values stored, you would go ahead and answer the question. So the total time, and this, we did find different values yesterday, but let's pretend that we didn't even do that. So now to answer the question, you'll say the total time equals, and this B minus A times 18, or 18 times B minus A, that's very, very important, because that shows me what you're doing with your numbers. And the advantage of calling it A and B on your paper/iPad is that you can, bless you, you can actually refer to them in your calculations as A and B, and that prevents you or keeps you from having to write the decimals down. And it's also a reminder that you're going to be using the stored values of A and B and not the truncated or rounded values, because anytime you're off in the third decimal in your final answer, you get the wrong answer. Okay, you're going to lose points. Now, yesterday we used two different values of T further down, and we got 25.841. We should get the same answer using different values of A and B, right? Let's see what we get. 18, parentheses, and then alpha B minus alpha A. And you get 25.841 or 842 would be the two answers that I would accept seconds. So there you go. That's how you would answer the question. Make sure you put units on your final answer, and you always indicate your method. The extra burden on a calculator portion is that you always have to show me exactly what it is you're typing into your calculator to get the answer. Okay, so an equivalent question like that could be asked for any height, right? The 100 was just kind of an arbitrary number. For how many seconds was he below a certain number? For how many seconds was he above a certain number? It's the same idea, okay? You could figure it out in one cycle, find the points of intersection, subtract, and then multiply it by how many cycles you have. Very important idea. Okay, any question on that part?
Can we practice when it says below?
Sure, yeah, let's make one up. We got time. This question right here, by the way, everything that's on this, these different parts, A, B, C, D, E, F, very, very similar to your free response question on Wednesday. So if this were the only problem we did from this section, that would be enough for you to understand the entire application of sinusoids. All right, let's make one up then for below. During the 3-minute ride, I spelled minute correctly there, comma, for how many seconds was he below, and let's see, let's do a tag team Kevin operation here. I'm the Kevin writing it down, you're the Kevin suggesting the problem, and we'll let Kevin the donut man give us a number.
Any number?
Yeah. 12. Okay. For how many seconds was he below 12 feet? Okay. Excellent. I like 12. I'm going to let you do that. Okay. You got a calculator? You got the question? Go ahead and figure it out. Now, part of the problem is already done because we know that he's going to be 18 cycles. All right. So if you haven't grabbed a calculator yet, go ahead and play along. Grab one up here. Practice your notation as well. Make sure you're writing down exactly what you think I would expect to see on your exam on Wednesday. I'm almost more interested in how you arrive at your answer than the actual answer itself. And if you're watching the video at home, this is your opportunity to do it as well. Say what? I'm going to let you figure that out. Graph it.